Good evening and I welcome you students. Chemistry theory paper term 2043 CBSE 12th class. I already solved section A of chemistry theory. It has been uploaded in the YouTube. You can watch it. I would be solving today section B, chemistry theory 043, maximum marks 35, time 2 hours, general instructions. Already we have discussed students in the previous video. Read the following instructions carefully. Before you begin any paper, it is our responsibility as student that we must read the instructions very carefully. There are 12 questions with internal choice. Internal choices have been given. Section A, we have already solved 1, 2, 3, very short answer questions carrying 2 marks each. Section B is going to be solved by me today. 4 to 11 are short. This was very short, are short answer questions carrying 3 marks each. Section C 12 is case based carrying 5 marks. All questions are compulsory, but internal choice have been given. Use log tables and calculators is not allowed. You are not allowed to use log tables and calculators. Let us begin our session. Section B straight away, students. Pay attention, stay focused, concentrate. Read each and every word very carefully before you answer the question. I will try to explain you in complete detail and we'll try to see what are the basic concepts involved in every question. Question number 4 is account for the following. You have to account, student. You have to write. Is a descriptive paper. Account for the following. Let us see what answer we are giving. A, aniline. When I write aniline, first of all, you already know, student, what is aniline. This is my aniline, students. NH2. Okay, cannot be prepared by ammonolysis of chlorobenzene. What he is saying, this is your chlorobenzene. And to make the things more clear, I am writing the Lewis electron dot structure. This is our chlorobenzene. Cannot be prepared by ammonolysis. Now, what do you mean by this? When I say ammonolysis, students, I am doing here is nucleophilic substitution reaction. Nucleophilic substitution reaction. What is happening? You have to replace the Cl by NH2 group. So if I want to convert this into aniline, this is an example of nucleophilic substitution reaction. So the base, this is the base, student, as you can see NH2 here. Now the question is, this reaction is not taking place. This does not take place. Why? What is the reason? Whereas if I take haloalkanes, the CCl bond is easily breakable, because let us see the reason. You already know, students, there are 2 important points here. This benzene ring is a sink of electrons. So you already know what happens, students. If I have this structure, try to understand everything. That is our main thing. So what will happen? This lone pair of electron can go to the benzene ring, and what you get, students, there is a double bond, partial double bond character is visible now, negative, and you can draw more resonating structure of this. So this is negative, this is positive. So what do you see here, student? The CCl bond in aryl halides, in chlorobenzene has partial double bond character. Can you see that? Has partial double bond character. Number 1. Number 2, this CCl bond, this carbon, students, this carbon is this CCl, the carbon of the CCl, this carbon of CCl in chlorobenzene is sp2 hybridized. sp2 hybridized. In haloalkanes, if you compare this with haloalkanes, that they are sp3 hybridized. So because it has a partial double bond character, sp2 hybridization, the CCl bond is shorter. Hence, cannot be broken easily, cannot be broken under ordinary conditions, students. So under ordinary conditions, the nucleophilic substitution of aryl halides is not possible, but haloalkanes is possible. These are the two reasons. So we have understood. Now let us see the answer B. What is the question in the A, B? N-ethyl ethanamine. What is, let us first write N-ethyl ethanamine. 1, 2 carbon, ethanamine, CH3, CH2, N-ethyl. This is my N-ethyl ethanamine. So this is a 2 degree amine. Okay? Boils at, he is talking of the boiling point, students. What is the boiling point? 329.3 Kelvin. Whereas butanamine, what is the butanamine? CH3, CH2, CH2, 4 carbons, butan, 4 carbon, and you have NHH, students. Here you have a lone pair of electrons, lone pair of electron. Nitrogen is electronegative, negative. Hydrogens are positive, positive. Nitrogen negative, hydrogen positive. So you know that when hydrogen is attached to highly electronegative element like nitrogen, oxygen, or F fluorine, it can form intermolecular hydrogen bond. Here you can see, students, in primary amine, butanamine is primary amine. So in primary amine, there are two NH, two hydrogens. There are two hydrogens attached to nitrogen. How many hydrogens? Two hydrogens. So they can form intermolecular hydrogen bonds. Whereas in the 2 degree amine, you see there is only one hydrogen which is attached to the nitrogen, which can form intermolecular hydrogen bond. So it is very clear that primary amine will have a higher boiling point because the intermolecular hydrogen bonding is more extensive in butanamine as compared to N-ethyl ethanamine. This is 1 degree amine. This is more 1 degree amine. So the boiling, you already know the boiling points of amines. 1 degree amine has higher boiling point than 2 degree, 2 degree more than 3. Therefore, butanamine has a higher boiling point than N-ethyl amine because there is a more extensive hydrogen bonding, intermolecular hydrogen bonding in butanamine because there are two hydrogens which can attach, form hydrogen bonds. Here you have only one hydrogen which can form hydrogen bonds. So we have to write, student, it is a descriptive. See you have to understand, try to understand everything and then answer the question. Answer C, acylation of aniline is carried out in the presence of pyridine. What do you mean by these, students? What is aniline? This is your aniline. What is an acylation, student? CH3, C double bond O, Cl. If I react with this, what will happen, students? This is again a nucleophile. This will attack this. And the result of this is that this carbon is positive. As you will see, there is a separation of charge. This becomes negative. So what will happen? At this point, this nitrogen is a nucleophile. It is attacking this. The result of this is what, student? You will get NHCO, CH3, and this is your. So what you are getting, you plus what you will get, this hydrogen and Cl, HCl. You are getting HCl. Now this is a reversible reaction. Why the pyridine is added? Pyridine is a strong base. Pyridine is a strong base. Stronger than aniline. Stronger than aniline. You know the structure of pyridine, students? This is the pyridine. This is a stronger base. then aniline. So this pyridine will react. This is a base and HCl is an acid. They will react. So pyridine will remove HCl. What the pyridine is doing here, students? What the pyridine is doing? So pyridine removes HCl. And this will shift the equilibrium to the right hand side according to the Le Chatelier principle. The reaction will be going to the forward direction as you will remove this. So pyridine removes HCl. Pyridine is a base and therefore shifts the equilibrium to the right side. Equilibrium to the right side. Hence, this reaction is carried out in the presence of pyridine. I hope you understand very clearly. Now let us see the answer which has been provided by the CBSE. The answer given is, in case of chlorobenzene, the CCl bond is quite difficult to break as it requires partial double bond character due to conjugation. We explained it. So under normal condition, ammonolysis does not yield primary aniline. We have given you two reasons for that. One, due to conjugation, there is a partial double bond character, then sp2 hybridization of the carbon. So you are getting 1 mark. It may get into half plus half when we have given two reasons for that. Primary and semin are engaged in intermolecular association due to hydrogen bonding. As we said, intermolecular hydrogen bonding is very important when we will discuss the melting points and boiling points. Between nitrogen of one and hydrogen of another molecule, due to presence of 3 hydrogens, the intermolecular association more in primary. There are no 3 hydrogens, there are 2 hydrogens. This is a mistake. There are 2 hydrogens. In the case of the primary amine, how many? This is our primary amine. There are 2 hydrogens. As you can see here, the inter is more in secondary amines as there are 2 hydrogen atoms available in the hydrogen bond. So if I have, this is 2 hydrogens in 1 degree amine. This is my primary amine, students. And in 2 degree amines, we have already shown. You have R and let me, you have, students, R, N, H, R dash. So there is how many? Only one hydrogen. So there are 2 hydrogen atoms. There are 1 hydrogen, only 1 hydrogen, which can form intermolecular hydrogen bond with another molecule, So more the number of hydrogens with attached to the nitrogen, which can form intermolecular hydrogen bonding, higher will be the boiling point. So you can make a correction here. There are only one hydrogen atoms, and tertiary, they don't have any hydrogen as such with the nitrogen. So their boiling point will be the least. During acylation of aniline, stronger base pyridine is added. This is done in order to remove HCl during the reaction to shift the equilibrium to the right side. We already answered that question. So this is the answer of the first. There is a choice here, students. Convert phenol. What is the formula of phenol, students? Conversions. Now we are talking of conversions. You have to convert phenol into what you are trying to do, N-phenyl ethanamide. What is the formula of N-phenyl ethanamide? Ethanamide, student, N-phenyl ethanamide. So what you have, students, if I have this attached to the nitrogen, N-phenyl, okay? Ethanamide, what will be ethanamide, students? CH3CO, this. So CH3, if I write CH3, C double bond O, NH2, student, it is clear. 1, 2, this is ethanamide. Now you are having a 1 hydrogen replaced by phenyl group. That becomes N-phenyl ethanamide. This is N-phenyl ethanamide. Now you have to convert this into this, students. Now, first of all, as it is clear, student, this reaction will involve more than one step. So in such questions, what will we do, students? How to answer such questions? conversions. I'm talking of conversions. So for these students, what I am going to do for this student, I will write this is my phenol. I will have to use not one, two, or three set of reactions to reach what I want to reach. What I want to reach, you have already seen. You want to get NHCOCH3 students. This is the final product you want. This is N-phenyl ethanamide, or so this is also called acetanilide. Common name is acetanilide. Therefore, I know that if I have aniline, if I have aniline students, then I can do the acetylation of aniline, CH3COCl. And this takes place in the presence of pyridine, is a strong base. We have just indicated you can get this. But how will you get aniline? So therefore, we have to perform something more. You already know that if I have NO2 nitrobenzene, and if I react with 10HCl students, reduction of nitrobenzene can give me aniline. I am going from here to back. Let me see what steps I'm getting. Nitrobenzene, how you get nitrobenzene? Nitrobenzene can be prepared, students, if you have benzene. Nitration of benzene. This is my benzene, concentrated HNO3 and concentrated H2SO4. Nitration. You are aware of the nitration reaction, student. Nitrate. How will you get benzene from this? You know, zinc dust. If I add zinc dust, zinc is a good oxidizing agent. It will immediately remove oxygen. It has a strong tendency for oxygen. It will immediately take off the oxygen from this, and you will get benzene, ZNO. Zinc undergoes oxidation easily. So what it will do, it will oxidize. So here zinc can be used to remove the oxygen from this. Therefore, these are the steps which we have to write. So conversion involves not one step. As you will see, there are many steps here, student. You can use tin HCl, or you can use iron HCl. All this, what reduction process. So the iron you can use, and you will get FeCl2 plus Cl. Therefore, you can see these are the steps. I have gone final product, first product, and all the steps you have to write. And then you are going to get a mark for this. This is on giving you 1 mark, student. You can see then maybe distributed half and half like that. Question number B, chloroethane. What is chloroethane, students? CH3 CH2Cl. What you want to convert? CH3 NH2. This involves, there are 2 carbons. How many carbons are there? 2 carbons. And there is 1 carbon. So how do we do the degradation, student? Now you talk of degradation series. You have learned a reaction in which if I have CH3CONH2 students, I can convert this into this reaction. I can reduce the number of carbon by 1. You are aware of this reaction of man's bromamide reaction. Hoffman bromide reaction, what you are using, Br2 and NaOH, then you get this carbon is out, you are getting amides are converted into amines. We have studied this reaction in the case of the reactions of the amides into amines. Now the question is, how do we get this? How do we get this from this? So for this, again, we have to do more reaction, students. You know that if I can convert this into CH3, C double bond OH, and I react with this with ammonia, then what will happen? If I react with ammonia, I can get an amide. Now, how will we get carboxylic acid from? We can use then CH3, CH2OH alcohol. If I have alcohol, student, I can oxidize the alcohol. Oxidation of the alcohol to carboxylic acid, acidified KMnO4 can be used. Now, how will I get alcohol from this? Again, I know if I have aqueous NaOH nucleophilic substitution reaction, OH minus nucleophilic substitution reaction. Therefore, now we can see the steps which we have written. It involves a degradation. We have reduced the number of carbon by 1. Hofmann bromide reaction is very important, and a lot of questions are there based on this. So we have to reduce the number of carbons. We can use Hofmann's bromide reaction. Hofmann's bromide reaction. Okay, what is the next part is saying propane nitrile. What is the formula of propane nitrile? 1, 2, 3. 1, 2, 3. CH3, CH2. This is our propane nitrile. Ethanol. What is the formula of ethanol, student? You want to convert to CH3, CH2OH. Now, again, student, here, what you are getting, how many carbons are there? 1, 2, 3. This has only 2 carbons. Therefore, we have to go through the same process. First, if I go CH3, CH2, CN. So if I do the acidic hydrolysis, this is called acidic hydrolysis. You know what you get, students? CH3, CH2, C double bond O, NH2. And then I do Hofmann's bromide reaction. You will get CH3, CH2, NH2. Now you have reached the amines with 1 carbon less. How you convert, students? How you will convert? You want to convert now propane nitrile to ethanol. So you know when amines are reacted with nitrous acid. How do you get nitrous acid? NaNO2HCl will produce nitrous acid is not stable. It is produced in the C2. Then this will result in the formation of CH3, CH2OH, ethanol. Therefore, this reaction is important. Nitrous acid can convert amines into alcohols, and nitrous acid is unstable. It is prepared in the C2. We react with NaNO2 and HCl. Let us see more questions. What is the answer given by the marking scheme? Marking scheme of this is our marking scheme. CBSC, zinc dust, nitration. This is wrong. This is not the. You cannot convert nitro into aniline. You have to do the reduction, tin or HCl or FeHCl, FeHCl, or you may use hydrogen or palladium as a catalyst. So this is acetanilide which you create. So chloroethane to methanamine, you have seen how we are oxidizing amide. What we have done, so we have converted that into alcohol. Alcohol oxidized to carboxylic acid, amide, and amide to amine. Okay. And in this case, what has been done, we have converted into amide, Hofmann bromide, then nitrous acid. This is ethanol. This is ethanol. Did he talk of ethanol? This is an aldehyde. In the question, what is given? The question, it is ethanol, students. So we have to stop at ethanol. If it says ethanol, then how to convert alcohol into aldehyde? This is pyridinium chlorochromate. If he said ethanol, students, ethanol is an aldehyde. And if you want to convert alcohols into aldehyde, you have to perform a controlled oxidation. Controlled oxidation reaction, student. If I use acidified KMnO4, it will form carboxylic acid. For that, you have used PCC here. Pyridinium chlorochromate. Pyridinium chlorochromate is a complex of chromium trioxide, pyridine, and HCl. So there is some mistake in the question. This is ethanol, not this ethanol is here. We stop at this stage. Another question is coming, students. Question number 5. Answer the following questions. A. Nickel. These are coming from coordination compounds. A. You have studied the coordination compounds. And the question is, this hexa-aqua nickel 2 plus is green in color, whereas this complex which contains En, you know, is a strong field, strong ligand. Water is a weak ligand as compared to En. Is blue in color, whereas this is green in color. So coordination compounds colors you have studied. What is the reason of the color of the coordination compound? You have studied, student, crystal field theory. You have studied the crystal field theory. What it says, when the ligands approach the central metal ion, what happens? The symmetry of the d orbital is destroyed and the d orbitals get split up into two orbitals. This is a octahedral complex. This is a octahedral. What we are talking is here octahedral coordination compounds. So in the octahedral coordination compound, this is octahedral crystal field splitting. What happens in this case, you already know, you have seen in the book, students. The 5d orbitals get split up into set of two orbitals. What you have? If you have 1, 2, 3, 4, 5d orbitals which were degenerate, what happens, student? When the ligands come, the energy becomes little higher. I'm saying 1, 2, 3, 4, 5. These are the 5d orbitals. And they get split up, student, into 1, 2, 3, and 1 and 2. And this is what we call as crystal field splitting energy. This is a crystal field splitting energy, T2G and EG. So in octahedral case, you get this type of splitting. Now what will happen? This is a neutral ligand. Water is a neutral ligand. The nickel is in which state? +2. Here water is neutral and also En. What is En, students? CH2, NH2, CH2, NH2. Okay? 1,2-ethane diamine. This is also a neutral ligand. This is also a neutral ligand. Nickel is in +2 oxidation state in both the cases. In both the cases, nickel is in +2 oxidation state. Then what has happened? There is a change in ligand. En is a strong field ligand as compared to water. This is a weak ligand. There is a spectrochemical series which has been given. You want to see in the NCERT book, spectrochemical series, which gives the strength of the fields. En is stronger field than the water. Then the splitting energy, what will happen? The splitting energy will be different in the two cases. It will delta 0 for this complex NiH2O4 En2 plus will be greater than delta 0 for NiH2O6 2 plus complex. Because the splitting energy is increased. Therefore, when DD transition will take place, color is due to DD transition. Color is due to DD transition of the electrons. So if I consider nickel, let me see what is the atomic number of nickel. I should remember scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. It starts with 21, 22 atomic number, 23, 24, 25, 26, 27. So where is nickel 28? Nickel is 28. That means it is the configuration of nickel. How do I write? 3D8 4S2. So if these electrons are gone, what is happening? 2 plus. Nickel is in 2 plus oxidation state. ठीक है? If the nickel is in 2 plus oxidation state, then what is the what will happen in this case? The electronic transition are going to take place from T to G to Eg. So if you write this is a stronger field and this is a weaker field, so what will happen? DD transition takes place in this case. This nickel 2 plus you are saying is 3D8, 3D8, 4s2, 2 electrons, they will be lost when nickel 2 plus will be formed. So DD transition takes place from T to U to Eg, and the wavelength or the frequency or the energy of light absorbed is different as the ligand is changed. The color depends on the strength of the field of the ligand, because En is a strong field, so this energy delta zero is more for this this ligand. It is more. Therefore, what will happen? There is a shift of the color from lower to a higher energy. As you will see, there is a shift. You have 7 colors: V, I, B, G, U, R. So the color is shifting from where, students? It is going from green towards the blue side. This is more energy, more energy. So the color change is due to the change in the strength of the ligand. So what we say, color is due to DD transition, and the color shifts from where the color is shifting from. The color shifts from green to blue because the strength of En ligand is more than the field strength. I can say the field strength of En is more than H2O. So there is a shift in the color. If I will change the ligand, again the color will change. I am trying to explain everything in detail so that there is no question left. Write the formula and hybridization of the following compounds. Now, what is this compound, student? It is saying tris. You know, base tris means there are three ethane 1,2 diamine, cobalt 3 sulfate. Let me see what I am trying to say here. Okay, tris ethane 1,2. Now, first, you know the rules. This involves the rules for writing Iupac name of coordination compounds. Now, I will say that students, you go to the NCERT and revise this if you have doubts, how you write the names. In this case, student, cobalt, the oxidation state of cobalt is 3. So if I write CO, okay, this, if I write CO, what is the formula of this compound? Is NH2, CH2, CH2, NH2. 3 he is saying. This is a neutral ligand. It is a neutral ligand. The oxidation state cobalt is 3 plus. And the sulfate is there, student. Sulfate, what is the charge of the sulfate? 2 minus. Now, when I will form the formula, you have to see that this 3 and this is 2. So then how do I do and write the formulas? You know that what happens when I will do. You have seen how to write the formulas of the compound, student. Then this 3 must go like this. So I would say the formula of the CO, NH2, CH2, CH2, NH2. This is a tris. Tris means 3. And you have here how many? This 2 charge coming from here. And how many sulfates you are getting, students? This 3 comes here. This is the formula for this. You have to write this formula. Now you understood how to write the formula of a compound. Rules. If you have problems, study the rules for writing the formula. Writing the formula. Okay, from the IUPAC name of the coordination compound. Both types rules. Try to study the rule. This will be the answer of that. All right. Let us see the answer which has been given by the marking scheme of NCERT. The color of the coordination compound depends on the type of ligand. DD transition taking water is a weak field ligand which causes smaller splitting, as we said, delta zero splitting crystal field is smaller, leading to DD transition corresponding to, however, due to presence of En is a strong field ligand, splitting is increased due to change in T2G EG splitting due to change in delta zero, which I have shown here. Splitting is increased and the color changes from green to blue, shifts to higher energy. Formula of this we have already told you how to write. And this important point, this is important point, students. Cobalt, another question is asked here. What is the other question? He's saying write the formula and hybridization. You have to also find the hybridization of the following compound. How will we write the cobalt is in 3 oxidation state. So how to find the hybridization? Okay, using the crystal field theory. How will you use a crystal field theory to find the hybridization? Cobalt is in 3 oxidation state, +3. What is the scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc? 21, 22, 23, 24, 25, 26, 27. So cobalt is 27, which means cobalt is argon. Electron configuration of the cobalt is 3d7 4s2. Now when cobalt is +3, what it means, students? This will be 2 electrons goes this and one, this is 3d6. So what do you mean by 3d6, students? If I have 1, 2, 3, 6 electrons. What is this? 1, 2, 3, 4, 5, and this is my 6. So 3d6, 3d. This is my 4s, and you have 4p. Now, how many? There are six donor atoms. So you need how many? 6. How will you get 6? Because you find En. This is a strong field ligand, student. What will happen when this will be coming? The formula you have written is CONH2. These are strong field ligands. You have En3. There are 6 donor atoms. 6 donor atom. You know, you can see nitrogen. There are 6 donor atoms. Neutral. This is a neutral ligand. So hexadentate ligand. So what happens? It is a strong field ligand. Check the spectrochemical series if you have doubts. Spectrochemical series have been given. What it will do, it will pair up these electrons. The result of that will be, student, if it gets paired up, what you get? 1, 2. This is already paired. This is paired. These electrons get paired up. So what happens? What will happen when this gets paired up, students? 6 electrons. Then you have, this is 3d, this is 4s, and this is our 4p, students. So now you need 6 vacant hybrid orbitals. So what hybridization is taking place here? Let me change the color of this. So students, you have these 6. 1, 2, 3, 4, 5, 6. So these electrons can come on this. What will happen? What hybridization is there, student? Then you are getting pairs of electrons. This will be D2sp3 hybridization. And that is an inner orbital complex. Inner orbital complex, students. Inner d orbital is used. And you can see that this has no unpaired electrons. This will be diamagnetic. It will be diamagnetic. There are no unpaired electrons. Everything is paired. So they are called low spin complexes. In an orbital low spin complex, it is diamagnetic. There are no unpaired electrons. So you see how I have found the hybridization. Certain things, certain information I'm trying to explain. So the answer which is given by the CBSE marking scheme is here, D2sp3. This is a formula. So this is how the marks are given, students. Formula of the compound is this. That means this should be half and then this should be half. That makes 1. And here also we have 2 explanations. So see the marking scheme also, how the marks are allotted. Another question is coming, student. In coordination and titrity, the electronic configuration of central metal ion is this. Again, this is showing the splitting, and this is example of the splitting, octahedral splitting. You have seen there are 5d orbitals get split up when in octahedral 6 ligands approach. How the splitting takes place already know, student. So how to answer this question? What we are trying to say, how many d orbitals were there? You had 1, 2, 3, 4, 1, 2, 3, 4, 5. So you already know you have dx square y square, dz square, dxy, dxz, and dy, dxz and dyz. There are 5 d orbitals. They are degenerate in an isotope. As a ligands approach, what happens? You have seen the energy. There's a rising energy, student. 1, 2, 3, 4, 5. And what happens? This is 1, 2, 3, 4, 5. Okay. So 5 I'm showing. And what will happen then when the ligands form crystal field? What happens? The electrostatic repulsion, then they get split up, student. The splitting takes place. You already know. I've shown a little bit higher. So the splitting is taking place. The result of that splitting is, you know already, students, what happens? 1, 2, 3, T2G, and you have to here EG. This is the splitting energy, delta 0. Okay? 5 orbitals are split like this, and this center is called barycenter. You can see the exact diagram in the NCERT book. Now in this you have 1, 2, 3, and 4. You know, there are 2 important points here. One is called, this is called the splitting energy. Splitting energy. And another thing is called P, the pairing energy, students. If the ligand is low field, ligand has a low field, low field ligand, then what happens? The splitting energy is less than P. Splitting energy is lower, then pairing does not take place. The next electrons, this is D4, it goes to the higher from, it does not pair up, but it goes to the EG, the next, which is higher. So in this example of the low field, and then what you are getting in this case is a high spin complex. High spin complex, because there are 4 unpaired. If it is D4, there are 4 unpaired electrons in this. 4 unpaired electrons. If pairing takes place, then what will happen? There will be 2 unpaired electrons. So this is the example of high spin complex. Is it high spin? Yes, it is an example of high spin because the splitting energy is lower than the pairing energy. As you can see here, there are 4 unpaired electrons in this. Now draw the first question. Draw the crystal field splitting diagram of the. We already have shown you. This is a crystal field splitting in this case. So it is an example of D4 case, and this is example of the high spin. Let us see the answer which is given. So the splitting is taking place as you have seen here. Ligand field theory, and first we discuss crystal field, now the ligand field theory. As the fourth electron, the answer which is given as the fourth electrons, one of the E giving configuration T23 Eg, which indicate delta 0 is less, hence it form high spin complex. That's what we are saying. And this is a energy level diagram which has been asked, splitting of the d orbital octahedral crystal field. So in octahedral crystal field, what is happening? These orbitals, the electron density is higher in the z and x y direction. Along the axis, there is more repulsion when the ligands approach by octa in the case of octahedral. So their energy is higher, and those which are having electron density or orbitals in between the axes, they experience a lesser repulsion from the fields of the octahedral. And this is the reason what you see, the three dxy, dyz, dzx, they are of lower energy. They are called T2G. This is called Eg. All right, this answers the questions. Another question is coming. Question number 6 is on the screen, students. What is saying? Account for the following. Titanium is more stable than titanium 2 or titanium 3. Now we are talking of transition elements. This is the 3D series. What you have? Scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. This should be learned by all the students. 21, 22, like this. It goes up to 30 atomic number. And you know the electron configuration are very important. Answers can be given on that. So you should be able to write the electronic configuration of titanium. This is titanium. This is argon, which is 18 electrons, atomic number 18. Then you have 3d2, and 4s2. These are S, these are D. So if you have titanium 4 plus, it has, this is the next, it has noble gas stable configuration. Therefore, the answer is there. We already said that more stable. Therefore, Ti4 is more stable than Ti2. Ti2 will be having 3d2 and Ti3 will have 3d1 electrons. That is not the noble gas configuration. This is a noble gas configuration. Hence, is the most stable. No problem in answering this question. In case of transition, ions of the same charge in a given series show progressive decrease in radius with increasing atomic number. Again, you see what is happening when I am saying in the transition element, if there is a same charge, if you have a same charge, what happens? These are the transition elements I have written. If I supposing M3 plus ions, I can take same charge, 3 plus ions, scandium 3 plus, titanium 3 plus, vanadium. The electrons are entering into the same subshell 3d orbital. And the result is that what will happen? Effective nuclear charge increases. Effective nuclear charge increase dominates. It will dominate. Hence, what will happen? It will show progressive decrease in radius with increasing atomic number. A descriptive paper you have to write, but you write limited and specific according to the question. Atomic number. Okay, that answers the question. Zinc is comparatively soft. Iron and chromium are typically hard. Let us see the electronic configuration of zinc. A lot of questions will be based on electronic configuration. The Zn, you are saying this is we have just shown scandium, titanium, chromium, iron, cobalt, nickel, copper, zinc. This is 30, you have said. So what was that, student? Argon, and this was 3d10 4s2. So there are no unpaired electrons. There are no unpaired electrons in zinc. So if the unpaired electrons are there, then the metal bonding, what happens to that? Is weaker. is weaker. If there are unpaired electrons, there is a stronger metal-metal bonding which takes place, and stronger the bonding, then what will happen? They will become hard. In the case of iron and chromium, they have got unpaired electrons. Zinc doesn't have unpaired electrons, and therefore there's a weaker metal-metal bonding. So it is soft metal. It is soft metal. Let us see the answers given by the marking scheme of the NCERT. What it says: titanium has electronic configuration 3-2. Titanium 4 is more stable as titanium 4 is the nearest noble gas configuration, which we already said. Titanium, we have shown you that it goes to argon 18, nearest noble. In case of transition, ions of the same charge in a given show progressive decrease with increasing atomic number. As new electron enters the d orbital, each time nuclear charge increases by unity. Shielding effect of d is not that effective. Hence, the net electrostatic attraction, nuclear charge, and outermost increases with increasing. There are two factors. One, we have already said, shielding effect, and the other is effective nuclear charge. Here, the nuclear charge dominates, so effective nuclear charge becomes more because the shielding is not that effective. Therefore, there is a decrease in size. Iron and chromium have a high enthalpy of atomization due to presence of unpaired electron. As we said, zinc has low because there are no unpaired electron. We have shown you the electronic configuration of zinc also to explain the answer. So this zinc you have already seen is argon 3d10 4s2. So no unpaired electrons. So the questions you try to understand. Let us go to the next question. What it says, student, an alkene is there. You have studied the ozonolysis reaction of alkene. You know what is an alkene? Molecular formula C5H10 CnH2n is an alkene. There should be a double bond, student. Ozonolysis reaction. What is an ozonolysis reaction of a double bond? Let me see, student. What it forms, student? Ozonide. You have studied this. Ozonide. And what happens on when we react with zinc H2S? These bonds will break, and what you get, student? You get two carbonyl compounds. Here he is saying you are getting compounds B and C. You get one is B, other is C. He's saying B gives positive Fehling solution test. Positive test. That means it is an aldehyde Fehling test. Fehling test means it is an aldehyde. Aldehyde. Is it clear? And positive Fehling test and also form iodoform test. Now, what do you mean by this? Is very clear when something is giving iodoform test, students. If I say it is giving iodoform test, students, then what it means? Iodoform test. Okay? Iodoform test will be given by, it is an aldehyde, and iodoform means there should be an alpha methyl. Okay? Compounds which contain alpha methyl groups, they give iodoform test. What they give, student? Iodoform test. You already know. They form CHI3, which is a yellow precipitate. Compound C does not give. Compound C is a ketone because it does not give Fehling solution test. Okay? Identify A, B, C. Write the reaction of our ozonolysis and formation of iodoform from this. So now the question is clear, students. I hope we can easily answer this. See that we have been able to draw the map of what is happening. Okay. Take the blue color. Okay. So what has happened, student? This formula is C5H2. And one of these you are saying aldehyde will mean, student, that if it breaks here, then this will give what? This will give an aldehyde. The formula is C5H10 1 2. Then what is left? CH3 and CH3. So if this is the story, then what happens? Then what is the ozonide? CH3 CH3 O CH3 students O. Now this is an ozonide, and you know what the zinc does. Zinc will take one oxygen and then these bonds will break. So what you will get, students? CH3 CH double bond O and CH3 CO CH3. This one B gives Fehling. This will give Fehling solution test, and this will not give Fehling solution test. It is a ketone. One is an aldehyde, other is a ketone. So we have identified, student, B and C. B and C is identified. Now what he says, write the reaction for ozonolysis and formation of iodoforms. The reactions, how will you write the reactions for the two of them? You first of all, you know what is a Fehling solution, student? There are two Fehling solutions, Fehling solution A and Fehling solution B. You know that how you do the test in the chemistry lab. ठीक है, Fehling solution A is your aqueous copper sulfate solution, and this is your alkaline. What is that? Alkaline sodium potassium tartarate. Sodium potassium tartarate. You mix the two in equal amounts. What you do, students? Mix the two in A and B. ठीक है, equal amounts. This becomes a Fehling solution. And what you get in this, you know that aldehydes give positive Fehling test. And that test is the formation of Cu2O, which is a red precipitate. These are aliphatic aldehydes. Aromatic aldehydes do not give this test. They do not give Fehling solution. I'm giving you more information than has been asked in the question, just to because we have to learn more and more, students. So what happens then if you have CH3 CHO, student? If it will react, you know, copper ions are there, and you can see the NCERT book there, student. You have that, and balance the reaction. What happens? This will be oxidized. This is oxidized, and what you get is Cu2O. That is a red precipitate, student, is a solid. You will see a red color and 3H2O. And again, if you have, if you want to see the iodoform test, in iodoform test, what you do, student? This is a alpha methyl ketone. So you have H. Let me write H here. Then you have C double bond OH. So alpha methyl ketones. They will give this test. And what you react with iodine, and you have NaOH, students. What do you get? CHI3, which is a yellow precipitate. You will get a yellow precipitate, and what will happen? This will give I and HI, 3HI, and what will happen? That this will get oxidized sodium salt. See, this is a story. Now, similarly, then CH3, CO, CH3, CO. One of this you already know, which does not give Fehling solution test. This is my C, and this is my B. The C, this will not give. This does not give Fehling solution test, but it will give iodoform test because it is alpha methyl ketone. So same, right? Iodine, NaOH, again CHI3, yellow plus 3HI, this is my yellow papt. Instead of H, you will have CH3, CO minus Na plus. These are the reactions which have been asked in the paper, which you have to give. This answers the complete question. Let us see the answer given by the CBSE. This is the marking scheme which has been given. He said that compound A is an alkene, it gives compound. As both B and C have CO group, B gives positive, so it is an aldehyde. Aldehyde gives itoform, so it is CH3CO. This means it is acetaldehyde. We already said that. C does not give, so it is a ketone. It gives positive itoform, so it is CH3CO. So these are the reactions which we have already shown to you, that what is happening. And also these are the tests. Filling solution. This gives Filling solution. Ketones do not give Filling solution. And iodoform test. Therefore, we have already answered the question. See the marking scheme. How? Half, half, half. Total marks are 3, but half plus half, half plus half, half plus half. So it becomes 1, 1, and 1. So total 3. How is the distribution of marks takes place? Every step gets a mark. Another question is coming on the screen, student. Observe the figure given below and answer the question. Now, you have studied the surface chemistry. And you have studied the colloids, very important. Colloidal solutions. Colloidal solution, very important topic. Here questions will be asked to you. And you have studied the purification of colloids. How do you purify the colloids? There are crystalloids. The size of the crystalloid particles is smaller than that of the colloids. So if I use a semi-permeable membrane, what happens? These crystalloid particles will pass through the semi-permeable membrane. And then what will happen? Purification of the colloid will take place. So that process is what we call as, you have studied dialysis. Kidney dialysis, you are aware of the dialysis. But here there are 2 electrodes, positive and negative. So what will be that? Then it will be electrodialysis. So therefore, what process is represented here? It is very clear. This is example of electrodialysis, because there are 2 electrodes, positive and negative. What is the application of this process? We already said this is used for the purification of the colloids. Purification of colloids. Can the same process occur without applying electric field? Yes, it can occur. That is called dialysis. That is what we call as dialysis. But dialysis is a slow process. So to speed up, we apply electric field, and the result of that is the oppositely charged ions will move towards opposite electrodes, towards oppositely charged electrodes. Positive ions will move towards negative plate, and negative will move towards the positive. So positive will move toward the cathode plate, negative will move toward the anode plate. This way the process of purification is speeded up, and that is what we call as electrodialysis. Let us see the answer given by the CBSE. Again, electrodialysis, purification of colloidal solution. Yes, dialysis is very slow process. Purification and this. Okay, the question is answered. Next question is coming on the screen. What happens when reaction N-ethyl amine reacts with benzene sulfonyl chloride? Student, benzene sulfonyl chloride. You have studied the Hinsberg test, student, is very important. Hinsberg test is used in the chapter of amines to distinguish 1 degree, 2 degree, and 3 degree. What do you use? Benzene sulfonyl chloride. What is benzene sulfonyl chloride? This is our benzene sulfonyl chloride. N-ethyl ethanamine. N-ethyl, if I write N-ethyl, that will be C2H5. Ethanamine, what is ethanamine? Again, CH2, CH3. This is my 2-degree amine. It has only one hydrogen. So what happens when it reacts? This will be lost, student. And what you will get? You are getting this N C2H5, C2H5. So what is this? This is N diethyl, N diethyl, N diethyl benzene sulfonamide. Now these are, there is no hydrogen on the nitrogen, no acidic hydrogen. So these are insoluble in alkali. Insoluble in alkali. If I add NaOH, it is not soluble. There is no hydrogen here. Therefore, this becomes a test. It will not dissolve in NaOH or KOH. And this is a Hinsberg test. This can be used to identify the distinguish 1 degree, 2 degree, and 3 degree. 1 degree amines become soluble in alkali. 2 degree does not become soluble. You can check this. You can check this, student. Benzyl chloride is treated with ammonia. What is benzyl chloride? React with ammonia, student. Then what you will get? You will get CH2NH2. So this is a 1 degree amine. 1 degree amine. Then react with chloromethane. So you have studied the alkylation reaction. Alkylation of 1 degree amine. Here there are 2 hydrogens. So what can happen? Students, if I use 2 of this, CH2 and CH3, CH3. So you will get N dimethyl benzylamine. Aniline reacts with chloroform. NH2 chloroform in the presence of potassium hydroxide. You have studied, student, isocyanate test. It has a very foul smell. Isocyanate test or a carbylamine reaction. This is also called carbylamine reaction. What you produce is isocyanides, which have very foul smell. It is a test for the primary amine, students. Both aliphatic and aromatic amines will give this test. So what is the result of this? You will get NC, which has a very foul smell, and you will get, student, 3KCl. Then there will be 3H2O. So this is isocyanide or carbylamine test, which has very foul smell. Let us see the answer given by the CBSE. When ethylamine reacts with benzene and then dimethyl sulfur is formed, we have given the formula, also shown the reaction. Which one reacts with chloride yields a secondary amine and methyl benzyl amine. Actually, we have shown 2 methyls. You can show the 1 methyl, then you will get N-methyl benzyl. The reaction is shown like this. What you have, students? When this is our benzyl chloride with ammonia, you are getting CH2NH2, and this is alkylation. CH3 when reacts with which is reacted with chloromethane. So alkylation. Only one. If I use only one, then what you get? CH2NH CH3. So this was 1 degree. This is 2 degree. 2 degree. I have shown two that you can stop at this stage, doesn't matter, because I only 1 mole is given, then no problem. So this is phenyl isocyanide or phenyl isocyanate test, which we have told you of how smelling. All right. Next question is coming, student. What it says, student? You have to write the IUPAC name of for the following compounds. This is, this is aniline and ethyl, methyl. E comes first, then so I can say this is N ethyl, N methyl aniline. We already know so well. Or benzene instead of aniline. You can complete the following. What will happen? This is a reduction. So this will reduce this. You will get NH2. And what is this? Br2. Then NH2 group is a strong activating group. And you already know what is the result of this. This will form 3Br and H2. There will be 3Br, highly activating group. It is highly activating. So this is our A. This is our B. Then NaNO2, N2 plus Cl minus. This is our C. And you have HBF4. So fluoroboric acid, you already know, students, what type of reaction is this. So Balz-Simon reaction. You have studied Balz-Simon reaction is used to prepare fluoro compounds. What do you get? Aryl fluorides cannot be prepared directly because it is a very violent reaction. They are prepared by this HBF4 fluoroboric acid after diazotization. So this is diazotization, and this is what we say fluoroboric acid. You know the name of this reaction. This is Balz-Simon reaction. Spelling should be known to you, student. SCHIEMANN reaction. This is used for the preparation of fluoroarenes. They cannot be prepared, student, by direct methods. Cannot be prepared directly because it is very violent explosive reaction. So they are done by Balz-Simon reaction. Let us see the answer given by the CBSE. All right, this is the answer. Reduction, bromination is a strongly activating group. You can see that strongly activating group, strongly ortho-para activating group. You have studied all this because there is a lone pair of electron, and what will happen? It will activate ortho and para position. And ethyl, this ethyl is wrong because it's not ethyl, it is methyl. So check, sometimes certain errors could be there. Another question is coming. Represent the cell in which the following reaction takes place. The value of E0 for the cell. What is the value of the E cell? First he says represent the cell. How do you represent the symbolic cell? How do you represent? We have told you A, B, C, student. What is that? Anode, salt bridge, and cathode. Anodic reaction, cathode. Which is the anode which undergoes oxidation? Which is undergoing oxidation here? Aluminium is undergoing oxidation 3+, and it is given 0.01 molar, students. And then what is happening? Cadmium 2+, 0.1 molar concentration. It is undergoing reduction to cadmium. So this is a symbolic representation of the cell, anode, salt bridge, and cathode. And if we have to complete the reaction, how will we do it? Aluminium is undergoing oxidation. ठीक है, 3 plus. Here he has given say 3 plus plus 3e. There will be 3 electrons. And what is happening, student? Cadmium is undergoing cadmium. Where is cadmium? Cadmium is undergoing reduction. Aluminium undergoing oxidation. Then cadmium 3 plus. You have cadmium 3 plus will get 3 electrons and you will get CD solid. Now this is cadmium 2 plus. Sorry. So you are getting this. There are 2 electrons. Now 3 and 2 electrons, you have to cancel the electron, multiply this by 2, multiply this by 3. Then what will be the final equation? So this 2 aluminium plus 3 cadmium 3 plus, ठीक है, 3 cadmium 3 plus will produce 2 Al3 plus and 3 cadmium solid. The concentrations are given. I have not written the concentration. And the number of electrons involved is 6 here. As you can see, 3 into 2, 6 electrons. There are 6 electrons, students, which are involved in this reaction. Important. That is the reason we calculated this. Now you know what equation to be used in this case. You are aware of the Nonstick equation. How the standard electrode potential values are at unity concentration. When the concentrations are changed or temperature is changed, then we use a Nonstick equation. For a general reaction, you know, A plus B, P. If it gives C plus D, and N is the number of electrons involved, then what we say? E cell is equal to E naught cell minus 0.059 by N. I'm not, you know already, I'm giving a shortcut of the formula. And then log of C power C, molar concentration of C raised to power C, molar concentration D raised to power D, and molar concentration A raised to power A, B raised to power B. You can see the book NCERT if you have any doubts. This formula we have already derived in our videos, lecture, solved it. And you know, for pure solids and liquids, liquids and gases at 1 bar pressure or 1 atm, what happens? We take molar concentration unity. These molar concentration or these concentration are taken unity for pure solids. Now in this case, what will happen then? Apply the Nonstick equation. The Nonstick equation will look like this. E cell is equal to E naught cell minus 0.059. N is 6 here. Number of electrons 6. Log of, this is the equation, solids unity, solid is unity. Then you have aluminium 3 plus the square molar concentration and cadmium 3 plus, cadmium 2 plus, how many? Cube. So put the values of the molar concentrations and you will get the answer. What is that? E cell is equal to, what is the value of E naught cell? How much E naught cell is given? E naught cell is given 1.260 volt. 1.260 volt minus 0.059 by 6. Log of aluminium is 0.01 into 0.01 and cadmium is how much? 0.1 into 0.1 into 0.1. So this is 10 minus 4. This is 10 minus 3. Answer will be 10 minus 4 plus 3, 10 minus 1. What do we get then? You will get E cell is equal to 1.260 volt minus 0.059 by 6 log of 10 minus 1. And what will be log of 10 minus 1, students? That will be minus 1 log 10. Log 10 is 1. So then it becomes 1.260 volt and minus minus will become plus 0.0596 into 1. So if you calculate this value, student, it is coming 1.260 volt plus around 0.009 volt. Add the two, 1.269 volt. So that is the value of the E cell. See, all the steps have to be written. Let us see the answer given by the CBSE. This is the answer which has been given by the CBSE. We already solved it. You see how you get marks. If you write this, you are getting half marks. And if you write this, you are getting half marks, this half, and like this, you are getting 1, and finally half. Like this, they are giving you marks, student. So half this, half, 1, 1, and 1 plus 1 plus 1. So total 3. This is the marking scheme. Next question is coming on the screen, student. Why are fluorides of transition metals more stable in their higher oxidation state? You already know fluoride is F is the strongest oxidizing agent. And in the higher it will form higher oxidation state. What will happen? The lattice enthalpy will be very high. Lattice enthalpy high and bond enthalpy high. Bond enthalpy will also be high. So they will be, if lattice enthalpy is high, they will be very stable. Which one of the following will feel attraction when a magnetic field is applied? Again, attraction will be felt by why? If there are paramagnetic substances, you know, paramagnetic, which means which have unpaired electrons. Now again, we have to find which have unpaired electrons. Here, you know, if I take titanium 4 plus, student, titanium 4 plus is nothing but argon, noble gas configuration. We have already said scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. We have some idea. 21, 22. So titanium 4 plus, this is what? This is a 3D2 4s2. So 4 plus will 0, 0. That means this is not, no unpaired electron. No unpaired electron. So it cannot be attracted. What about cobalt 2 plus? Let us see. Cobalt 21, 22, 23, 24, 25, 26, 27. Cobalt atomic number 27. 27 will mean what, student? Argon. And what you have? 3D 7 and 4s2. So this is 27. 4s2, 3d7. So there are 7 electrons in the D, means what? 1, 2, 3, 7, 1, 2, 3, 4, 5, 6, and 7. Cobalt has got 3 unpaired electrons. Therefore, it will feel attraction. So it will be attracted by magnetic field. Okay, paramagnetic. Ag plus, what is the story of Ag plus? Where is Ag plus coming, student? Copper and silver, you know, in the same group. This is copper 29. If you add 18, 47, that is silver. And you know, in Ag plus will be 4D, 4D10. So Ag plus 4D10, no unpaired electrons, no unpaired electrons. It cannot be attracted. And Zn2 plus, you already know, Zn is here 3d10. So no unpaired electron. Then which is being attracted here? You are clear. This is cobalt 2 plus. So cobalt 2 plus is the answer, which will field cobalt 2 plus. It has unpaired electrons. It has been observed the first ionization energy of 5D series of elements are higher than 3D and 4D. You have studied, when we talk of 5D, there is an intervening 4f orbital, and this has the poorest screening, poorest shielding or screening. So the result of that will be the outer electron will experience greater attraction, and therefore the first ionization energy will be higher. Let us see the answer given by the CBSE. The answers given by the CBSE are on the screen, students. The ability of fluorine to stabilize highest oxygen is attributed to high lattice enthalpy or bond enthalpy. Cobalt has 3 unpaired electrons. We have shown you. Transition 5D are intervening 4F. There is a greater effective nuclear charge acting on outer due to weak shielding of by 4F. You know the shielding is poorest for the F. If you are knowing the shielding effect, the S has more shielding than P has more than D, and F is the poorest. So the shielding is the poorest, very, very weakest in this case, in the F orbital. So the 4F is involved, then it will become weak. On the basis or choice is given on the basis of the figure, answer the following question. Why manganese has lower melting point? Where is manganese? This is the manganese. So scandium, titanium, vanadium, chromium, manganese, 21, 22, 23, 24, 25. The electron configuration of manganese, let us see. This is argon, and you have 3d5, 4s2. So half filled, it is half filled, extra stable. Half filled extra stable will mean the d subshell has maximum exchange energy. So the 3d electrons are held. 3d electrons have extra stability. They have maximum exchange energy. So they are held more strongly by the nucleus. Held more strongly by the nucleus. They are held more strongly by the nucleus. So they are less delocalized. They are less available for bonding. So the result of this is there is a weaker metallic bonding. And when the metallic bonding is weaker due to extra stability of 3d high orbital, the melting point will be lower. Melting point is lower, students. Okay. Why do transition 3D have lower melting point as compared to 4D series? Again, it is decided by the metal bonding. So the as the heavier metals have stronger metal bonding. The 4D they are the heavier metals have stronger metal bonding. And when the metal bonding will be stronger, the melting point will be higher for 4D as compared to 3D. In the third series, identify the name which are the highest melting point. Third transition. This is the first transition series, second, and this is my third student. You can see W, tungsten. Tungsten has the highest melting point. Let us see the answers given by the CBSE. Manganese having lower melting point as it has highest number of unpaired electron. Not only, we should say that it has extra stable D5 configuration, which we have indicated. So strong interatomic metallic bonding has no strong interatomic metallic bonding. We are saying the metal bonding becomes weaker. So something, check the answer which I have given. There is much more frequent metal bonding. Where there is more metal bonding, that is in heavier transition metals. Therefore, this will account for higher melting point of 5D than 4D. Tungsten already answered, no problems here. So students, we have answered all the questions which are given in section B. The last question which we answered for section B was 11th question. So that ends up the section B, and therefore we will continue with the next section, which will be section C next time. Okay, I hope I have made everything very clear and explained to you in complete detail. The section A has been uploaded, and this is going to be uploaded, and you will get in the YouTube. So you can subscribe our channel and forward it to your friends. Try to learn, try to understand. Don't mug. Mugging is not going to help. Okay, then student, bye bye. My best wishes to all the students who are appearing for the 12th CBSE exam. And then I see you in my next video. Bye bye.